Hello, imagers, and welcome to the November meeting of the Kalamazoo Astronomical Society's Astrophotography SIG meeting. And yeah, we were hoping to be in person, at least some of us were hoping to be in person for the second time ever at Western Michigan University's Rood Hall. But 2 days ago, I sent out a reminder about tonight's meeting, and then like a couple hours later I decided to go check the weather, which is really unusual because once the permacloud comes in November, I kind of just stopped looking at the weather. What do I care? I know it's not going to be clear. And then I saw there's a winter storm warning in effect, and sure enough, we got at least a foot of snow here. So I am very glad to be here on Zoom, where everyone I know is safe. No one has to drive home. I'm not going to hear about any car accidents or any mishaps like that. So I know when we started meeting in person again back in September, I mentioned, well, if the weather's ever bad, we can always meet on Zoom instead. And I figured that would be like January or February, not frickin' November. So I didn't expect to have to do this so soon. But again, it is great to have you all here tonight. We got a great turnout. Currently, we have 55 participants, or at least 55 logons. I know some of you are watching with friends or family at home. And again, it is great to have you all here. And we got a fantastic speaker for you tonight. I'm not going to do the usual introduction because we really just had him not too long ago. So tonight's speaker, you can see him outside there with the red lighting. He first joined us back in February. It was Lloyd Simmons that recommended tonight's speaker back in for the meeting he joined us for in February, and he gave an excellent presentation on planetary imaging. That was, I think, the meeting that we probably talked about the most out of all the first season of astrophotography SIG meetings that we did, starting late last year. And during his presentation, or after his presentation, really, he mentioned the possibility of coming back and doing a kind of live imaging session with Mars, which is going to be at opposition here in just a few weeks. And it's really unusual for us to have, a speaker in back-to-back years, let alone the same speaker twice in 1 year. But we figured we can't refuse his offer because we'd have to wait another 26 months to do this again. So we're doing something a little bit different tonight. It's going to be much more of a demonstration than a presentation. So at any point during his demonstration tonight, you are welcome to chime in with questions, because that's why we're here. We're not just going to wait till the end of his talk or whatever, because it's not really a talk per se. And we're going to kind of learn as much as we can about capturing images of Mars, because he's going to do it live so long as the clouds stay at bay. So without further ado, I'm going to welcome back Agapios Elia from Cyprus. So Agapios, thanks for joining us.
Good morning, everybody. Thank you so much for having me. This is my 3 a.m. face, so I apologize if I look weird. Welcome to my backyard. I'm outside now, about to do some Mars imaging. I've already done some Mars imaging, and I'm just going to follow up now. It's great to be back with you guys. I had an absolute blast last time we met. You're an excellent crowd, and it was really a fun night. So I'm really glad that I get to do this again with you guys. So as Richard mentioned, this is not going to be a talk, a presentation per se. So I'm not going to be blabbing on and on. This will be a little bit more interactive. So please, at any time, just feel free to step in and ask any questions or anything you want to discuss. So we keep this going. So as I said, I'm outside. This is my backyard. I'm coming to you from Cyprus, which is an island in the Mediterranean Sea. And well, it's pretty much clear all the time here. But tonight we've got a band of clouds coming. So I think we have about 10-15 minutes before they become a problem. And I'm outside with my telescope. I'm using a typical C9¼ Schmidt Cassegrain on a German equatorial mount. I've got all kinds of accessories that if you want, we can talk about. And I'm actually using a brand new sensor tonight. This is probably maybe the second or third time I'm using it since I got it. I've got at least one new piece of gear since the last time we met that we can talk about as well. So this is the Player One Saturn Color 533 sensor. And even though I've only used it maybe twice so far, it's been fantastic. It's been a really, really good sensor. So hopefully we can use it and get some good data tonight and see what we can do. So I keep looking up because I want to make sure that the clouds are staying away. It's been a beautiful night so far. So I'm just going to go ahead and share my screen. Let's see.
What's the temperature there?
Let's see what the sensor says. So right now we're at 13 Celsius. I don't know what that is in Fahrenheit. It's all right. It's comfortable. So here we are. I'm using Fire Capture. I'm sure most of you know this software, more or less. I think it's probably the best option out there for somebody who's serious about doing planetary imaging. All kinds of tools and features we can talk about. This is the live view that we're getting now. And the scene is, I'd say it's fair with some good moments. I can pick out some detail. Let me just try and focus. So Mars is coming up on opposition and close approach. So Mars is going to be the largest that we're going to get, I think, on December 2nd. Right, one of those two dates is when Mars will be the closest. And for this time around, Mars is going to be 18 arc seconds across, roughly. So this is pretty much as big as it's going to get. Just trying to focus here. I don't know how well you guys can see the live feed coming. I'll make out some details.
That looks great.
Okay, I'm just trying to focus. I think we talked about this the last time. Fire Capture has this amazing tool that you can use for really precise focusing. It's called the auto align feature. That's what I'm using now. So what this does is, as the images are coming in on your preview, Fire Capture is actually centering those frames on the target, so you can touch your telescope and focus without having the planet wobble around on the screen. And it's really, really helpful. I actually don't really use my motorized focuser that much because this is just so effective. Only when seeing is excellent, I can, only when I've got excellent seeing, I can actually see the benefit of the motorized focuser. Most of the time, I'm just using this. Okay, that looks about right. And I'm just going to center this. Okay. So, as I said, this is a new sensor. This is the 533 color sensor. It's relatively large. Let me just turn on the full screen. It's a 3000 by 3000 pixel size. Just get this out of the way. Let me just show you just how large the sensor is. So there's tiny Mars on this huge sensor. And what I'm going to do is, because I want to get as high a frame rate as possible, I'm just going to crop out a smaller part. And this will allow us to maximize the frame rate here. So this is the number of frames per second that we can record. And let me just crop that down a bit more. It's gone up to 125. Now it's going up to 150. Let me just adjust the exposure here a little bit. Okay, so now we're up to about 200 frames per second, which is fine. Turning off the debayer, and let's just do a quick capture. So what I found is this sensor is actually a little bit slower than the 224 that I've been using up to now, but it's got really low noise. It can take a lot of processing before it starts to show any noise, and that's great. Let's see what we're getting now. All right. Okay, the cloud is keeping out of the way. That's good.
How come you turned off the bearing?
Because
image capture.
That's a great question. So what you can do is, if you're recording in color, file sizes are going to be much larger, and you don't actually need to do that because when you record your file, you can put it into AutoStacker, which we're going to do later, and AutoStacker can translate the color information and sort of make up for the fact that we're recording in monochrome. But recording in monochrome saves a lot of file size. Okay, so we just got one. Let me just turn on AutoStacker. Am I sharing the entire screen? Can you see AutoStacker coming up?
No.
No, just the
No,
file
okay.
capture. And I see you did 90 seconds.
Yes.
Is that what you recommend on Mars?
Well, I found that with this size telescope and this kind of camera, 90 seconds is good enough. You can obviously go less. You can even go further. You can do 120, you can do 180, but it depends on your resolution capacity. So the higher the resolution you have, the shorter the time that you can record an individual file. Even though when you throw it in AutoStacker can actually compensate a little bit for the planet's rotation. Let's see, how do I fix? I think now I'm showing the whole screen.
Yep.
Okay. So I'm just going to open the last file that we got, which would be this one. Okay. So what I'm going to do, I'm going to crop away all that dead space because we don't really need it. Scrolling through the frames, trying to find a good one. Let's see. So the interesting thing about Mars this year is that it's positioned in a way that it's giving us equal views to the northern and southern hemisphere. It's called an equatorial projection. So we're looking straight down the equator on Mars. So we get equal views of the northern and southern hemispheres. And I don't know for you guys, but for me, it's actually really high in the sky this year. I'm getting it up about 70, 72 degrees maximum altitude, which is always welcome. Okay, there's a good frame.
What is your latitude in Cyprus, Agapios?
I'm at 34.
Okay. Yeah, that's a little lower than us.
Yeah. Just making sure it's still there. This is a really old mount and it's got a lot of backlash. So I'm worried about the tracking. So I'm going back and forth from auto stacker to fire capture just to make sure that the planet is still there. Okay. I'm just doing a sort of a on the fly processing here just to see what kind of details we're getting.
What kind of computer do you have for processing? Like how many cores or RAM?
This is a 5-year-old i7. I'm not sure what the cores are on this. I think it's a quad core, and it's got, I think, 12 gigabytes of RAM. And it's been more than up to the task of handling anything I throw at it. Okay. All right, so this is the first stack. And I'm just going to apply some sharpening here. Yeah, the seeing is not really that good. Okay, there's some detail there. Obviously, you can see the extended northern polar cloud here on Mars. And there's been a lot of dust activity the past few weeks, not to the extent of past apparitions where we had global dust storms, thankfully. But there's been a lot of fine dust activity, especially in the southern hemisphere. I mean, all over here, there's a lack of contrast when this happens, and it's pretty obvious here as well. And a lot of other imagers are reporting the same thing. Let me see if I can improve that a little bit. Again, this is just a preview. It's not by any means a finished result. It's just so that we can see just what kind of details we're getting. And I can pull up a previous result I did maybe 4 hours ago. Let's see. So this was 4 hours ago, much better than what we have here. And we have the iconic Cyprus Major and the Hellas Basin visible here, as well as the northern polar cloud. Yeah, this was much better than what we have now.
Yeah, very nice.
Adequate. Okay, so yeah, we've lost Mars. Switching back to
how many
full screen.
images were stacked?
Sorry?
How many images were stacked on that picture, image?
So it was a 90-second
90 seconds, right? Okay.
90-second file, about 200 frames per second,
Yeah.
and I stacked about 15% of that. So if we do the math, I think that's,
Yeah.
I don't know, maybe a couple of thousand. Okay, so we lost it a little bit. Let's see. Oh, it's in the cloud. The cloud is here. Okay. Yeah, I think it's going to be in and out of clouds for a little bit. So we can just go back to processing. I don't know if you guys have any questions about the processing side of things. Oops, there it is. It's back. Yeah, it's just going in and out of clouds now. I don't think we're going to do anything usable. Let's just wait a little bit. Okay. let me just open one of the previous videos, which were much better, and maybe we can do a full processing on these. Okay.
What was the bit rate that you capture at? Is it 16-bit or 14 or even 8?
No, I think it's 8. At the moment, I think it's 8. Well, with this sensor, I think this is a 14-bit sensor.
Yes.
But in any case, I always capture the lowest possible, because that, again, that contributes to much higher frame rates. And when you end up stacking many thousands of individual frames, you're not losing anything in terms of depth and resolution. So you really shouldn't worry about the bit rate. Just use the lowest that you're able to, and just make sure you're getting enough signal to compensate for that. For me, the key has always been getting the fastest rate possible during capturing, because the seeing here is really variable. I think we talked about it during the last meeting. So it's never a case where I have the same kind of seeing over an extended period of time. It's always going in and out of different states, poor, fair, some moments of good, back to poor, maybe a glimpse of excellent, back to poor, back to fair. So it's always, going in and out of all of these states. So you really have to be as quick as possible, so that whenever those moments of better seeing happen, you're capturing as many frames as possible. And I've been using this approach for a good number of years, and for me at least, it's been very successful. And this is what I recommend you do if you're really into doing, if you're really dedicated about planetary imaging, is spend the time to sort of get to know your local seeing conditions. Spend a few nights, try to compare predictions with actual conditions, and see how your local seeing behaves. And if you're lucky enough that you get extended periods of uniform seeing, then you can forego the really high frame rate approach, and you can be more comfortable with, maybe slower frame rates. But you really need to, spend the time out there with your telescope, with your system, trying to decode your local conditions. That's what I've been doing, and I find that I only get maybe 1 or 2 nights a year where I have uniform seeing conditions. Most of the time, it's a complete mess, and I'm just trying to extract as much detail as I can out of those mostly poor to fair conditions. So I'm just going to do another on the fly processing here.
There was a question in the chat if you're using any filters.
Not at the moment. I actually have a filter wheel here, and I have a few filters. I only use a near infrared, which is really helpful when it comes to collimating. But 99% of the time when I'm capturing, I do it in RGB, one-shot color. So I only have an infrared blocking filter in here. Okay, so what's happening here?
Are you using your atmospheric the prism thing?
Dispersion
Uh,
corrector?
Yeah.
It's on the telescope, but it's at minimal input because Mars is really, really high. It's at 70 something degrees. It's almost at the zenith. So there's a minimal use for it at the moment, although there is some benefit even at that altitude. It's not the
one thing
case
I've already
like,
learned.
yeah.
Is how to put the ADC on the histogram. That was a nice. As soon as I saw that on your screen, I thought, "Oh, that's a nice place for it," and I had to go find it.
Yeah, and the latest version of Fire Capture actually has this always visible. There's a tiny ADC prism evaluator. It's always there. That's really helpful because you always have an eye on atmospheric dispersion, and as soon as things start to degrade, you can go in and readjust. So yeah, I don't think we're gonna do anything else with the live feed, at least not until the cloud clears a bit more. And you can see that the seeing has gone really terrible at the moment. So let's just go back to the previous recordings. Am I coming through okay? Because I think I have some network issues.
No, you're coming through fine.
Okay, that's
Great.
good.
It's great.
That's great. So which one was it? Okay, that's not bad. That's actually rather nice. Okay. So good thing I was out earlier. At least we caught some good data for tonight.
So if you don't debear when you record in Fire Capture, is there a particular setting in AutoStacker to use?
Yes. So you need to know what the Bayer matrix array for your sensor is, but you can just set AutoStacker to automatically detect it. If you come here under color, you have auto detect, so it's going to do its best to try to determine what the actual decoding should be. But if you already know what it is, you can get the information from your manufacturer. You can just have it preset. So RGB, so there's the option is already enabled here. So it's sort of translating. As soon as you load the files, it's already translating the color information. I think for this sensor, I think the difference is roughly 30%. So the monochrome file is 30% the size of the color file. So that saves a lot of
yeah, that's big savings.
Yeah, it's a lot of savings in file sizes. And when you're capturing many consecutive files like I used to do, I mean, I may end up with anywhere between 200 to 600 gigabytes a night. So you want to have as much savings as possible. Okay. As you can see, the seeing conditions are terrible. Almost nothing visible on the live feed other than a vague orange circle. But even though, even under something as bad as this, you can still extract some information. Okay. Okay, there we go. Another thing I use very frequently is Fire Capture's auto run feature. This allows you to pre-program a series of exposures. So I'm just going to ask it now to do 10 continuous exposures, 90 seconds in duration each. And I'm just going to center Mars as best as I can and just let it run. Let's just focus again. Yeah, the clouds are still a problem, but we're just going to let it run and see what we get.
I've used the auto align and the auto guiding features in Fire Capture. Have you found that either of those have any impact to the frame rate?
In the sense that when you're using auto guiding, you can crop down your sensor even more, especially if you have a relatively good mount, not like this one, but if you have a really a precise mount, you can really tightly crop down the sensor area that you're recording, so that will contribute towards your getting a higher frame rate. But the auto align, not so much. I don't really use the auto align when I'm capturing. I use it mostly for when I'm focusing, because when it freezes the planet on the screen, so you can focus better. But if your mount is well behaved, why not? Go ahead. But the main benefit is that you can really crop down the frame size, and that gives you a higher frame rate. Okay,
there's a couple of questions in the chat, or at least a comment. Mohammed asked, are you using auto stacker together with Registacks, or do you find one better than the other?
Oh, that's interesting. So auto stacker for the initial stacking, Registacks for sharpening and some stretching and color adjustment. And before auto stacker, we used to do everything in Registacks, which was a pain, because Registacks would have to go through each process almost in real time. So if you had a 60-second video, it would go and spend roughly 60 seconds going through the initial evaluation, then another 60 seconds roughly to go through the alignment, and then the stacking, and so on and so on. But with auto stacker, it's a much more optimized piece of software. So it does the first couple of stages almost instantaneously. And actually recently, the author of Registacks popped up on Cloudy Nights, and he started a thread where he said that he's currently working on a new, not so much an update to Registacks, but a new piece of software, a more modern and optimized piece of software for the sharpening.
Nice.
That would be really interesting to see where that leads. But yeah, auto stacker is the software you use for the initial alignment and stacking. Really powerful. It can handle I've been throwing 150, 160, nearly 200 files at once on AutoStacker, and it's been handling them fine. And it's versatile in the sense that it can do multiple passes, so you can do up to 4 different stacks for each file. It's been really indispensable. I haven't actually used Registax for stacking in a decade or so.
And then we have a request. Can you show the clear image of the process photo for about 10 to 15 seconds so I can get a clear screenshot?
Well, I don't know if we can send it in the chat. Is there a way we can do that? We can share it in the chat?
I don't believe so, no.
Okay. Let me just pull this up. There you go.
All right, everyone,
So this was before. This was at 21:48, so that would be 12:48 local time. So that was about 3 hours ago.
Well, what is that light green color on the top? On the
top where?
in the of the image right there, a little further up on the ice cap. What is?
Oh, you mean this?
Yeah.
Oh, so this is we pushed the sharpening a bit too far. Let me just try and do that one again. Even though this is the most satisfying part of the entire process, the wavelets, this is where most people just go over the top, because, you know, as you're adjusting the sliders, you get more and more detail coming out to a point, and then you start introducing all kinds of artifacts and stuff that are not really there. So you need to be really careful about what you're doing here.
Balancing.
Yes, and again, for me, the softer approach is better. You can still show the entirety of your resolving capacity and have a more balanced and softer final result. You don't need to be over, because then you risk the introducing artifacts in your image, and when you have artifacts in your image, then it's no longer usable. Certainly not in any, you know, scientific way. It's just an overstretched picture. So I think that's a little better. Okay. Should you see that there for a bit?
There's another question in here. Is there any value in using drizzle when processing?
You could argue that for targets like Mercury and Mars, you know, tiny targets, you could. I don't personally. I've never been a fan of drizzling, because I think that you don't really need to do that. If you can, if you have a really well collimated telescope, and if you have if you happen upon good seeing conditions, and if you take care in your processing, your result will be detailed enough where you don't really need to over exaggerate presentation. So I've never really gone into using drizzle.
And then the other question is, how do you get the fire capture screen larger, or at least the font size larger? That's in the chat.
you can adjust the fonts and the overall layout through settings. I'm not sure I understand what the first part of the question was.
The screen size. The screen size larger.
You mean the capture screen?
Yes.
Oh, okay. So there's presets here on the top here under image. Now we're using a smaller region of interest. We've actually selected a smaller part of the entire available sensor, but you can switch to maximum. So depending on what sensor you're using, these numbers will be different. They correspond to your actual sensor real estate, let's say. So for this sensor is 3000 by 3000 pixels. And there's presets here, all kinds of presets that you can customize to suit your system, and you can just toggle through those. Okay, so for some reason, even though we can do 200 frames per second, we're only doing 100. I think this has to do with the computer. Maybe Zoom is taking up resources, so that's costing us half our capture speed.
Well, we appreciate the sacrifice. So would you say your settings here for gain exposure, they're pretty typical?
Yes, and I would recommend that you don't really pay that much attention to what settings people use. Make your balance,
Right.
gain and exposure on your system so that you're getting a relatively healthy histogram. If you go the high frame rate approach, you don't really need to worry about gain being too high, because you end up stacking so many frames. It's not an issue, but don't look for specific settings, especially from other imagers. What you want to do is go out with your own telescope, your own camera, and adjust your parameters so that you're getting a relatively healthy frame rate with a relatively healthy histogram. So right now I'm actually a bit higher than what I'm usually comfortable. I try to shoot with roughly 50% histogram. And the reason for that is, as you can see, especially the green channel, it's jumping around quite a lot because of the seeing. So even though a lot of people recommend that you shoot at roughly 70-75% histogram, for me, that's too close for comfort, because I would be risking clipping or oversaturating. And I don't want to lose that information. So I step back to roughly 50%, and that has no detrimental effect. And that ensures that I'm not losing anything. But again, if you're lucky enough to have excellent seeing conditions, you can just go ahead and capture at 70, 80, whatever works for you. So I think that's looking a little better. Let's see if we can focus again. Oh, we're still capturing.
Any tips on focusing? This is so fast. Obviously, you can't use an autofocuser, but are you just trying to get the as sharp some of the time? I mean, it's blobbing half the time. It's hard to.
So when you do this time and time again, you're gonna develop sort of a hunch as to where your perfect focus is for your own system. So I know how my telescope behaves, and I know roughly how much range I have to hit perfect focus. But yeah, there's really no benefit to using a motorized focuser unless the seeing is really good. Not at the moment. I usually just go by hand by looking at the screen. Okay, let's just do another run. Okay, the clouds are gone.
I remember watching a presentation by Christopher Go on YouTube a while back, and I remember, I might be remembering a little wrong, but he basically said, don't use gamma. He even wondered why they even put it in the program.
You can adjust gamma when you're trying to focus in some occasions, especially when you're doing deep infrared or ultraviolet. That can be helpful a little bit, but for 9.5% of the time, there's no reason for you to adjust the gamma at all. I don't think I know where that is actually. I've never messed with it. Oh, there it is. Okay.
I don't know if you mentioned, are you using a Barlow or a PowerMate?
Oh, yes. Good question. So let me just describe my image train here. So the telescope is the C9.25. There's I've got an additional external Crayford focuser in the back. It's an old Moonlight CS. I've swapped the motor that came with it to a Pegasus Astrofocus Cube, which is excellent. And on that, I have the filter wheel, and I've sort of Frankensteined the ADC to accept the optical element from my my old Barlow lens, so that the element is closer to the sensor than it would have been if I had it in its original configuration, and the ADC, and then I have a manual rotator that's really handy when it comes to framing, and then the camera. So there is a Barlow, but it's stuffed inside the ADC. So I think for this configuration, we're roughly at 5.5, 6,000 millimeters focal length, the way this thing is configured. So for the C925, that's about f/25. I would say that what happens is a lot of people tend to obsess about things they shouldn't, in a sense that they worry too much about the focal ratio, they worry too much about capturing settings, they worry too much about processing settings, and all of these things are nothing compared to what really matters, which is how good your seeing is and how well collimated your telescope is. If those two things are not, if you don't really pay attention to those two things first, nothing else will improve your image, at least not in any meaningful way. So I would advise you spend most of your time trying to comprehend collimation and seeing. When you get those two things right, then everything else is just secondary. So don't really obsess about settings or that sort of thing. The name of the game is seeing conditions and proper collimation.
Yep. And of course, you have control of one of the two.
Yes.
You mentioned last time you use MetaGuide to collimate.
Exactly, yes. So a MetaGuide, originally being an alternative guiding software, has a powerful tool in the sense that it can identify miscollimation even under really bad seeing conditions. It's reading the area disk coming out of your system. It knows, well, obviously you have to set some information, just like you do in PhD, pixel size, focal length, all that. So it knows what to expect from your system, and it's evaluating what it's getting when you're recording a star. So it points you, literally it points you in the right direction so that you can adjust your collimation and get perfectly collimated. And I've been a really huge proponent of MetaGuide. I've talked about it a lot in forums and in sessions like this. And I really think the man deserves an award, Frank, the author of MetaGuide, because for me at least, it has been indispensable, and it's become an integral part of my routine. There is no scenario where I would set up and I would not use MetaGuide to collimate. There's no point. Maybe this will come out a bit harsh, but there's no point in using tools or anything to collimate. Since you're going to be outside under the night sky, just point to a star and use MetaGuide, and that would be 100 times better than anything else.
If we have the time, it might be worth to maybe do a quick demo of MetaGuide. I'd like to see it in action. I haven't used it much yet.
Oh yeah, we can do that.
Yeah, I'd be interested. I used MetaGuide years ago, but I didn't think the modern CMOS cameras would work with it.
Okay, so would you like to do that now?
Yeah.
Yeah, sure.
Okay. All right. Let's just stop this. Okay, so I'm switching to full resolution. Oh, it's still capturing. Okay. Okay, so the whole premise of MetaGuide is you point to a star. Let's see if we can go to, okay, so excuse me while I point my telescope. Okay, so El Nath, I think, is the one next to Mars at the moment. So let's just go to that. Okay. Let's see. So I'm just topping up exposure and gain. Okay, so there's a star. So what I did now is I defocused the star considerably, and I've upped the exposure and gain. So the star is not a tiny point now, but a much bigger donut. It makes it a lot easier to find things this way. There it is. So what I'm going to do is I'm going to center the star as best as I can. You want your star to be at the center of your sensor, because for two reasons. One is we're using a Schmidt-Cassegrain telescope, and this does not have a flat field. So you want to be at the center of the optical axis, because that's where you know, the field is at its flattest, and also because we have an atmospheric dispersion corrector in the imaging train, and that also produces a lot of aberrations off axis. So we want to be on axis. And the other thing we're going to do is we're going to switch to near infrared. Just get that. Okay, that will do. We're going to switch to near infrared. So I have a 610 nanometer filter. I just switched to it. And I'm also going to focus. So you have to be in focus with MetaGuide. So I'm just going to focus as best as I can. Before we go into MetaGuide.
Do you know offhand what the latest version is?
On MetaGuide?
Yeah.
No. I think it's 5
I
something.
believe that's 610.
Oh, it's up to 6. Okay, so I think I'm as focused as I can be. There we go. Okay. So what I've done so far is I've centered the star and I've focused it as best as I can using fire capture. And I'm going to switch off fire capture and turn on MetaGuide. Okay. So first thing you do is you select which camera you want to use with MetaGuide. It's really important to remember that MetaGuide uses the older direct show driver. So you need to download that for your camera before you can use MetaGuide. So make sure you do that first. So I'm just going to choose my camera. And here's the preview screen. And first thing you want to do is you want to go for these highlighted buttons here to go into setup and make sure you set up your profile for your equipment. So I'm using a 235 millimeter f10 with a ×2 Barlow, and my camera's pixel size is 3.75. And also under the extra tab here, I'm using a 610 nanometer filter. So you need to make sure that you input this information for your setup. I'm just going to click apply. And let's try to enhance. And here under video properties, you can adjust your gain. There's a star. I don't know how well you can see that. There's a star right there. And I'm going to turn on the crosshairs. Okay. So the whole idea is you want to have your star in the crosshairs as best as you can. At least for this telescope, it's crucial. If you have something like an Edge HD that has a much flatter field, so that may not be that critical. But for this telescope, that's crucial. Okay, so now we have it in the center. And we want to adjust gain and exposure so that we're getting the pattern. Okay, so here in this blue window, this is our star. And can you see that red dot bouncing around?
Yeah.
Okay, so this dot is an indicator of the direction of the star's flaring, which is a symptom of miscollimation. So what the dot is showing us is where we need to push the star towards to improve collimation. Now, what you want to observe is the behavior of the dot. It's going to be bouncing around, but it's going to indicate a preference. So I don't know if you can see it on the screen, but it's showing a clear preference to the right side. Sorry, to the left side. Do you see that? It's spending more time on the left than it does anywhere else.
Yep.
Okay, so what I need to do right now is I need to go up to my secondary mirror. Let's see if I don't knock anything down. So I have Bob's knobs on this telescope, so it's really helpful. Okay, so what I need to do is really gently adjust So now I'm adjusting so that I'm pushing the star towards the direction that MetaGuide is suggesting. And you need to be delicate here. You don't need to do any massive adjustments. And now that I've moved the star, I want to use my mount to recenter it to evaluate what we did. Let me just try and get it. And you want it to be as centered as possible. Okay. So now the dot is spending more time on the right side of the image. See that?
Yeah.
That means we overshot. So what I'm going to do, I'm going to go back. Okay, hopefully that will work. Recentering again. This mount has so much backlash. It's long overdue for a tune-up.
Should this collimation work with any type of telescope, like a Newtonian or?
No, this is primarily for Schmidt-Cassegrains or similar. You can use it with, what else is similar? Takahashi Mulons or CDKs. I'm not sure if you can use it with a Maksutov, but primarily it's for Schmidt-Cassegrains. Okay, so this is a general idea behind what you want to do with MetaGuide, and the other great thing about it is because it's primarily a guiding software, you can connect your mount to it, so it can automatically recenter the star when you're doing any adjustments. So instead of me trying to recenter the star with the hand controller, whenever you're doing an adjustment, MetaGuide can issue commands to the mount and bring the star back to the center every time. This is really helpful if you have a larger telescope. I don't know, something like a 14-inch or something, where you have to reach up much higher. That's really beneficial. So once you've tuned your collimation screws so that the dot is not showing any preference, that's when you know that you're collimated. And as I said before, for me, this has been indispensable. And it doesn't really take that much time. Once you get to know how the software works, it's a matter of a few minutes. So there's no reason for you not to do it every time. Yeah, so I'm on 551. I'm not sure if that's the latest. I don't think it is. The moon is out as well. I don't know if you guys want to have a go at the moon.
Sure, why not? Let's see, maybe a silly question, but did you turn the collimating screw clockwise or counterclockwise to go to the direction of the star?
I understand the point of the question. It took me a long time to get my head around what each screw does. So I did a clockwise movement to push the star towards the direction of the suggestion on MetaGuide. But yeah, it really brings back painful memories. I spent so many nights trying to understand what each screw does. It was really a pain.
Thank you, Adam. Yeah, you saved me a lot of time.
Oh, hey, Vasily. Hi.
Hey, how are you, man?
Good. How are you?
I'm fine.
So should we go to the, should we try the moon?
Yeah, why not?
Yeah.
Okay. Even though we're out of topic?
Yeah. Yeah, it starts with an M, that's close enough.
Oh, we may not be able to because I'd have to do some rewiring because we're going to have to point the other way. So let's just go back to Mars, stay in the topic as well.
Sure.
Okay. There we go. Okay. So now Mars is gone down enough that we can probably start to pick up some dispersion, so we can show the ADC. Okay. Okay, so for adjusting dispersion, again, you have to, first of all, switch back to RGB. You want to have your target centered again. And let's just go into Firecapture's ADC tool. Okay, so now Firecapture is giving us an evaluation of the chromatic dispersion it's reading off of the sensor, and I can adjust my prisms so that I minimize the separation of these circles. So this is what I'm going to do now. I'm going to start spreading a little bit. Just keeping an eye on the screen. And again, this is also seeing sensitive. So under bad seeing, it's going to be much difficult.
Oh, I missed it. Where does the ADC tuning window pop up at? How'd you do that?
It's right here.
Oh, okay.
Okay, so that's tuned. The circles overlap sufficiently, so that's done. And as you can see on the little preview here, we have mostly zeros and ones, which is a great sign. It means we're well tuned. And I'm going to drop the exposure and attempt to refocus. Yeah, the seeing is terrible tonight, guys. But it's clear. There we go. Okay, I think that's about as focused as we can get it under these conditions. Okay. Let's just do another run and see what we're getting. So I can see that there's activity in the chat. I don't know if there's any questions we want to address.
There's nothing new,
Okay.
but if anyone has any questions, feel free to ask or comments.
Is anybody doing planetary imaging?
You mean right now?
No, in general.
Yes. Yes.
Yeah. Okay. That's good.
I believe Kalamazoo is snow covered today, isn't it?
Yes.
Yeah, not today.
We're going to have clouds to at least March now. Yeah. So we're done.
Yeah. I was up there last year driving from Battle Creek to Kalamazoo in a snowstorm. So I know what you're saying, guys.
Yeah, I started planetary imaging with my 12-inch Newtonian.
Oh yeah, I remember you had some issues with getting the right Barlow, I think, was it?
Yeah, I ended up getting a 3x Barlow.
Mhm.
Now I just got to work on my collimation. Actually, I got a new carbon fiber tube being made in Germany by KAS.
Yeah.
So I'll have a really stable collimation after I get that together. But I've been really enjoying the planetary.
That's good. Another improvement you can do if you haven't already done it on Newtonians is well, this mostly applies to visual. Is installing a smaller secondary mirror that will really help with increasing contrast and reducing glare.
Okay. Yep.
So now, as the planet is now descending, you would want to readjust the atmospheric dispersion corrector frequently. Usually I stop every about 15-20 minutes just to reevaluate things and you know, fine tune it and adjust it again. But now that Fire Capture has this ADC preview always on, that's a fantastic tool. You can just keep an eye on that, and as soon as the numbers start to go, you know, up significantly, you can just pause there and go ahead and adjust your dispersion corrector. So we're only doing 24 frames per second. I don't know why that is. Our exposure is probably, yeah, there we go. Yeah, there we go. Back to normal numbers now. This is what happens when it's 4:30 in the morning. Brain doesn't work.
Yeah, we should probably wrap it up here in the next 5 minutes or so.
No, I'm good. I'm good.
Okay.
Don't worry.
How long do you keep your recordings? I mean, the video capture, because that's one thing I noticed is I'm running out of hard drive space.
So for Mars, I discard the video files as soon as I stack them. For Jupiter, I hang on to them a little longer because I participate in an impact detection collaboration project, and I keep those at least for a few days until the project coordinator gets the report that I submit, just to make sure that there's nothing, you know, any suspicious impact on any of those files. Once they clear the data set, then I would go ahead and discard the video files, because they can pile up really quickly, really quickly. But I know at least a few imagers, they just collect hard drives. I have no intention of doing that, so I after I'm done with stacking, I have no other use for the raw files. I may keep under excellent seeing. I may just keep a couple just for reference, but most of the time I delete them almost straight away.
Okay.
If you are of the mind that you just want to keep them, just know that you can get 2 terabyte flash drives on Amazon for $20.
Oh yeah. Yeah. I just ordered a 20 terabyte drive.
So those help. No
Well,
bigger than a
just
mouse.
keep in mind that you're talking a healthy 500 gigabyte total per night. So a 2 terabyte is what, 4 nights?
Well, it'd probably be one night. Throw it in the drawer.
Yeah. Okay, let's just go and do another stack and see if things improved.
Yeah, we have a question from Sherry. Robert, I don't know who Robert is. Will this be available to view tomorrow on the KS site? I hope so. I'll try to get it up tonight or sometime tomorrow when I have to shovel snow again.
Let me just say congratulations on an excellent website and newsletter. I've been following you guys for some time now, and you're really doing a great job when it comes to communicating your activities and everything that you do. So kudos to you for doing that.
Well, thank you. I appreciate that. Those are both my babies, the newsletter and the website.
Oh, congratulations then. So yeah, not much going on here.
Yeah, when you get a nice processed image from tonight, you can send it along and I'll put it in the newsletter. I'll try to.
I can do something better. I can share the entire, well, not the raw files, but the total stacks. I think we've got like 25 captures. So I'm gonna do a pre-processing on all of those, and I can share a folder with those, so you guys can get the data and try your own processing. And I'd be very happy to help out. You can reach out, email, and give pointers on how to do process.
Great.
Yep, perfectly clear now. I don't know if you've been out. If you have any clear skies, just go out and just look at Mars. It's really gotten really bright, and the red color is really obvious because we're so close to opposition. It's striking to the naked eye.
I did get to view it visually during the lunar eclipse, so that's the first time I saw it really high in the sky.
Oh,
because it's like 3 in the morning, 3, 4 in the morning.
This is the best time of the night.
Why is that? Because it's quiet?
There's nobody else awake.
Just you and the vampires.
Yeah, and well, the birds are going to wake up soon. So when they start singing, you know, it's dawn is upon you. I hope you guys get, you know, a chance to observe and maybe even image Mars in the coming few weeks. Now is really the time when we're close to opposition.
Yeah.
And even with a small telescope now, it's large enough to show great detail. This time around at 18 arc seconds, so that's roughly the same size as Saturn, the main planet, not the rings. So with a decent telescope, you should be able to resolve at least the North Polar Cap, and when features such as Syrtis Major is visible, that would surely be easily visible. So I hope you guys get a chance to go out and see it. So that was 19,000 frames for a 90-second video. That's why it took so long to analyze it. And we're stacking 15%. And let's just go into okay, let's see. Okay, so there's some detail.
Yeah.
Even under poor seeing, there's some detail you can make out. So we can see there's sort of a split here in the northern polar cap. We can just about make that out. And some more cloud activity down at the South Pole. I don't know if it's cloud or dust. It's not really easy to discern. I think it's clouds. And some surface features. But yeah, no, seeing conditions are nowhere near as good as I've had recently. Hopefully this will improve. I mean, now we're slowly going into winter here. So conditions are gradually changing to much cooler and more unstable. But hopefully I'll get at least a couple of good nights and maybe produce some good images.
A question back on your camera. I
Yeah.
assume you don't need a cooler.
No.
I-
The
I-
reason for that is because the exposure length is tiny compared to a typical deep sky exposure.
Well, I'm just suspicious that dragging 200 frames a second for hours at a time, that doesn't make the chip warm.
No, not really.
Okay.
Even though actually this camera is actually running significantly warmer than the previous one I had, the 224. This is actually warm to the touch after some time. But no, the noise levels are so low that you don't need to worry about that, not at all. I've seen people attach, aftermarket coolers, and even I think even the company actually supplies an add-on cooler, but you don't need that with these short exposure lengths. Actually, this sensor is so low noise. The whole generation of these sensors, the noise levels are so low that even though they're uncooled, you can still produce really respectable deep sky images as well with them. It's sort of a shift in the trend, just because they're so efficient.
And you get a lot more signal with the planets than you do deep sky objects, right?
Yeah, exactly. I had hopes for better seeing tonight, but oh well. Well, that's it. Okay, so I think we have a good amount of data. So I'm gonna go ahead and pre-process all of that, and I'm gonna share a Google Drive folder with that data, so you can log in and download it and have a go at processing yourselves. And as I said, I'm more than happy to reach out and share tips on processing.
Yep, I will email the link out to the membership, and I can also put it in the description on the YouTube video that I'll create for this. So if you're not a member and don't get the email with the link, you can probably find it in the YouTube description video. Yeah, and as Kevin pointed out in the chat, it's Dave Wolf's fault for buying a new 14-inch Schmidt. So the weather's his fault. That's the way.
Well, I hope you get good images with it.
Yeah. All right. Well, thank you very much, Agapios. That was great. I learned a lot.
Thank you, guys. Thank you for keeping me company. I've had a great time, and as always, I'm available on email. Reach out. I'm more than happy to answer any questions and give pointers.
Wonderful. All right, I'm going to stop sharing here. So Let's just run through the rest of the agenda. We won't spend too much time on stuff, but the first thing is we want to share recent images. We can start with typical, maybe deep sky images or something like that. So if anyone has anything new to share, like Mumbauer, I did see a new image on your AstroBin page. I don't know if you wanted to share that.
Yeah, I'm pulling it up right now. Let's see here.
Just wanted to say a big thank you to the Kalamazoo team and Agapios. Thank you guys and have a great night.
Thank
Thank
you.
you.
Thank you, Vasily.
Okay, I'm gonna share my screen, maybe.
You just got to wonder who around the Buffalo, New York area got a really big telescope since they're
Yeah.
getting 70 inches of snow from the same system.
Jeez.
Oh, wrong window. That's my. There we go. Maybe.
That looks like the same window.
How's that?
Whoa, that's very skinny.
Very skinny. What are you seeing?
For a minute there, it just got really narrow. I don't know what that was.
That was the narrowband image.
Yeah, very narrow.
Okay. We'll do this one. How's that? Wait.
That looks fine.
Okay, cool. Yeah, so this is IC63, the Ghost of Cassiopeia. It's literally, if you look here, right, and you see the little box in there, right where I'm imaging at. I think that's gamma, possibly. So I mostly threw a lot of H alpha at this, 50 by 600 seconds at f4, and then processed it with some RGB for the stars. I used Russell Croman's excellent star removal techniques, so I could just enhance the nebulosity and add the H alpha without cooking all the stars up. Yeah, total exposure time of 12 hours. I did do about 16 hours worth of O3, and there really isn't much O3 here. So it was just when the moon was getting out, I was, just throwing data at this object. So I'm pretty happy with how this one turned out. Processed in PixInsight. Yeah, that's about it. And then the snow came.
And then the snow came, yes. Any other new deep sky images before we get into the eclipse? All right, no. So we had a lunar eclipse on, what day was it? November 8th? I forgot what day the eclipse was on. But I went out, it was a very early morning. And I set up my 5-inch refractor on my Astrophysics Mach 1. And I was going to start with a video if I could find it, because I created a video. Oh, that's right. I can't share the video when it's like full screen. So let me go back. Okay. I forgot about that. Okay, we're going to try it one more time. There it is.
I'm not the only one having problems with sharing.
I forgot you can't share it when it's full screen for some reason. Okay, so you should see the full moon there, right? Right.
Nope. Negative.
No. Oh,
Blank screen.
can
Yep,
you guys still hear me?
Yep.
Okay, Zoom's having issues again.
Okay. Oh, there it is.
On the moon.
Okay, we're not going to send it. Okay, no.
Burn. Now he's muted. I will unmute Richard. Ask you to unmute.
Am I back? All right,
You're back.
let's try it again. How's that?
There we go.
Yay.
Okay, so this, I believe, is a 1/500th image of the moon with a Canon 6D. I already mentioned that it's a 5-inch stellar view. It's a triplet. And I believe the ISO is 100. I always try to go as low as I can with moonshots like this to keep the noise down. And so I just figured I'd create a little video of these. I believe they're all the exact same exposure. And so I meticulously centered the moon from each frame. Each image is taken every 5 minutes. So it's not a really smooth like time lapse, but here we go. It's very short. So you can see that shadow creep across the surface. And there we go. One more time. Of course, you can see Tycho and Copernicus. And that's pretty much the limit of my moon knowledge. Well, I know
Vishnu,
Plato.
was there a specific software you used for creating the animation?
No, I just used the ordinary Windows Movie Maker. That's all I can usually manage to use. So it's very, very simple. I basically aligned it in Photoshop and then just stitched the frames together in the Movie Maker, and that's it. So very, very simple. And then about 30 minutes before totality, the clouds came in. And so that kind of ruined the rest of the eclipse, you know, the really important part of the eclipse, totality. But this image, you can't tell because it turned out fairly well considering the conditions. This was taken through clouds. You know, clouds moved over the moon at different portions of the 10-second exposure to basically reveal the whole thing, because you couldn't really see the whole moon at once visually. But with the 10-second exposure at ISO 400, I managed to take this picture here. So this was my best shot. And this was actually my last shot, because after that, the moon was gone. And so I packed up and went home.
Which one of those pinpoints is Uranus? Did you get Uranus in the shot?
I think Uranus for us was too far away. I think you had to be further out west to really have it
A little bit far away.
in the field of view. Yeah, I don't think it's here.
Great
Plus,
shot.
it maybe didn't get to the clouds if it would be there. I'm surprised I got stars.
Because I did see a picture, and somebody said actually they had a 10-second shot that showed it. So when you said 10 seconds,
Yeah,
it's like, oh, one of those two dots is probably Uranus.
yeah. I think it was too far away. They all look like
Yeah.
stars to me. There's nothing blue that stands out.
We actually got an occultation of Uranus by the moon a few weeks ago. Managed to capture that. I don't know if you would like, I can maybe quickly just show you that.
Sure.
Okay, let me just go and find it. It was a really challenging shot, to be honest, because the brightness was so different between the moon and Uranus. And let me see. Don't let me hold you. I mean, you can go and show something until I have it.
Hey, Richard, I could show my Jupiter I did the other.
On here. Can others hear Richard talking?
We cannot hear Richard.
No. He probably fell offline again.
Oh, I'm sorry. I hit my burp button and forgot about that. I didn't think you guys wanted to hear me chew on my ice, so I hit the mute button.
Well, here's my keeping us oops. Why does it always jump up there? Oh, we'll move it up here then. Here's my Jupiter that probably my best planetary image so far. Can you see this?
We could see it, but then it disappeared.
Oh, can you see it now?
There it is.
Oh, okay. So this is my 12-inch with the 3X Barlow with a IR cut filter and a ZWO, the 462 MC, running at 151 frames a second.
Nicely done, Pete.
Thank you. Yeah, yeah, right around 4,000 focal length for my scope.
Wow.
Yeah, it was a night of not super good seeing, and I could see it snap in and then snap out, and I'd try to start it and it'd be too late, and it's really it's definitely fun.
All right. Did anybody else want to share any pictures? I know both Muhammad and Arya had some lunar eclipse pictures. They sent me some.
I can.
Yeah,
Can
go
I-
ahead. Yeah, go ahead, Arya. Share your screen.
Can you see me?
Yep, we can see your desktop.
As Richard said that before the clouds move in, I was able to focus a little bit better, but when the clouds came in, I couldn't focus that much. So this before the eclipse started. So the first three, and then slowly, this is the time we got the clouds, and focusing was very difficult. I'm not sure whether this is the Uranus, but I'm not sure. Or this one, the blue one. That's the last one.
All right.
Nice.
Yeah, it's difficult to get shots when the clouds roll in during the best part.
Do you think that this is the my Uranus, the likely
That might be
blue color?
Uranus. Yeah, it could be.
Right here.
I can show the occultation images.
Oh yeah.
Okay, let's see. Okay, so this, can you see it? This is just before
Oh, yeah.
Uranus crept up behind the moon. Obviously, this is a composite, so it's a different set of data for Uranus and a different set of data for the moon. But I've used intermediate exposures to get the positioning information, so that I pasted Uranus over the exact position. So this is before, and this is after it had reappeared, and this was really dramatic because obviously Uranus came up out of nowhere seemingly behind the shaded part of the moon, and just looking at it through the live feed, hovering over the rugged landscape was surreal. So it was a really interesting event. Technically, it was quite a challenge, but I'm pretty happy with the way these turned out.
Nice.
Yeah, it looks good. There's supposed to be an occultation of Mars coming up for us, isn't there? Like December 8th or 7th or something like that?
Yeah, I'm not going to see that. You guys are so lucky.
Yeah, well, we're not going to see it either. So I'm trying not to think about it too much. We could get
All right,
lucky,
so
though.
I'm going to leave you guys.
All right.
Great. Thank you.
Thank you so much for having me. It was great. And see you soon.
Yeah,
Thank you.
thanks. Thanks
Thank you.
again, Agapios.
Have a good rest.
Yep.
Thank you. Thank you.
Yeah, get some sleep. All right, so let's book through the rest of the agenda here.
I got one question.
Oh, yes, go ahead, Kevin.
Arya's picture of the moon, can he put it back up when we thought, because we were wondering if that was Uranus?
Sure. Arya, you want to put up like that last picture?
Sure. Not sure which one.
I think it was the last, the wide
The
shot
last
with the
one you
tree.
showed.
Yeah, with the trees in the foreground.
Right here.
Yeah, that could be.
Yeah, that's it. Actually, from West Michigan, Uranus was at about 11:30 position, not at 6 o'clock.
Oh,
That's just a field star.
Okay.
okay.
I've got
somewhere
Sky
here.
up right now. It's
Well, if it's 11:30, it might be off the screen or out of the
No,
field.
yeah,
I mean,
it's
this is not a telescope. This is just a camera with a.
right. But Uranus was probably about
Somewhere
3
here.
moon diameters to the northwest,
Up and to the
Okay.
left.
Yeah.
up and to the left.
Okay.
Out of the field of view.
Yeah.
Yep. Can this
That
be the
star
one?
we were seeing was Omicron Aries. That star at below the moon is Omicron Aries.
Okay. Can this be the one? No.
Now Uranus would be up at the left.
Yeah, the left.
11:30.
Okay. Somewhere.
That just looks like a pixel to me there.
It would be. It's out of the frame there.
Oh, okay. 3 times the.
Yeah, it'll from the full moon. It's 3 lunar diameters to the
Oh, okay.
at 11:30.
I get it.
Whoa, you're gonna give us vertigo there, are you?
All right. Thank you.
All right.
Thanks for
So-
showing that.
One thing we always like to do is share images from other astrophotographers. So if no one has anything to share, let me share a few things that I've seen. One goes back from over the summer, so let me get that going up here. I wanted to get on the right screen. I emailed this one to both Pete, and I also emailed it to Kurt Karista, who's a professional astronomer at Western Michigan University, because I was really curious about these horizontal striations in this planetary nebula called the Bear Claw Nebula, or Sharpless 2-200. And even Kirk didn't know what exactly caused these. So these are really interesting. I've never seen a feature like this in a planetary nebula before.
Can it be a Dyson structure?
Yeah, it's a Dyson sphere. Exactly. It's a Dyson sphere under construction.
Well, that's where the bear scratched it. See,
So you can see for this is well in, yeah, it's probably why they call it the Bear Claw Nebula, because it looks like bear claws. So this is up in Camelopardalis. And so this is one we can get with, say, the remote telescope, or of course your own backyard telescope. So I'm going to try to go after that one.
That's a pretty big planetary nebula for it's an 8-inch f4 with the 294, so it's not like a monster field of view. That's pretty big.
Yeah. So you can see this was the image of the day on October 2nd. I thought it was over the summer, but no, it's more recent than that. And then, of course, there's a couple apod images that caught my eye. This was apparently taken with a 1 meter plane wave. And I believe this is in Pavo. So it's a little further, or no, Fornax. So it's a little too far south for us, I think. But I thought this was a really impressive image.
Mm-hmm.
And this was the apod for November 16th. And then this one's from October 26th. And I've never seen an image of the Cocoon Nebula that shows the dark nebulosity as actual dark sooty clouds. Usually, it's like black. So I thought this was probably the most remarkable image of the Cocoon Nebula I've ever seen.
Mm-hmm. Yeah, and this is all RGB too, because I saw a thread on Cloudy Nights by this guy, or maybe it was in PixInsight, but he describing this. This is a pure RGB image. Usually it's H alpha to get all this red. So it's, yeah, very remarkable.
Yeah. Alrighty, so those are just some of the images that I saw that I thought I would share. Moving on here real quick. Any new astrophotography related equipment or software anybody purchased recently? I know Mumbauer, he's always buying something.
I got my new collimation camera, where for Newtonians, where it goes into the eyepiece a 2-inch and it actually puts up a reticle and everything, so you can precisely center the secondary and the primary mirror. It's made by Rigel Systems.
Oh, I'm not familiar with that.
Yeah, it's pretty cool. They just came out with it. He actually shipped me an entire new unit because he did an update within the last month of me buying it. So he shipped me a whole nother unit. But seeing I don't have my new telescope tube and it's too cold outside, I haven't tried it yet.
Yeah, I'd like to see that in action. We should do a little demo of that sometime.
Yeah, it's really nice because it'll self-hosted onto a website, so you just bring it up on your phone or your iPad through a Wi-Fi connection it broadcasts, or through a USB cable, and then you just watch a live screen of what you would normally put your eye over. So,
and Dave, have you had first light with that 14-inch yet?
Just barely. just we tried to put some Bob's knobs in there, so I got an assistant with me because there's no way I can look at the eyepiece and then reach around to figure out which knob to turn right, and we discovered that they sent me the wrong knobs, so I had to get those correct ones. And then in the intervening time, then a permacloud sets in, so it's just sitting there, and then there's no way to get at it now. Even with my 4-wheel drive, I wouldn't dare try to drive out in the field with it.
Yeah.
I got a small question for you.
Sure.
I'm thinking about getting this sky tracker. There's this one. Does anyone have a experience of this one?
Yeah, Kevin.
This is mainly for my camera and lens. Not to put the telescope. Is it a reasonable one?
That's a good one. That's the one Kevin has. I know. Is Kevin still with us, or did he drop off? Because Kevin used it for the 2017 eclipse and he had great luck. But a bit newer one is the one that I shared last month. There's the Skywatcher Star Adventure GTI.
Yeah,
that has full go-to, Arya. It's a little bit more
more
expensive.
I remember the white and green one, right? So yeah.
Yeah, it's white. Yeah. Yeah, there's green in it. Yeah.
Yeah.
But the new Star Adventure is really great. It's the newer version of that one. It's not that one.
Oh,
but
okay.
It's the GTI.
Okay. The new boat recently. Okay.
Yeah, it's basically just a little German equatorial mount, but it's classified as a sky tracker. But it has all kinds of great features. It really is just a little miniature German equatorial mount. So I would look at that one as well.
Oh, okay. Thank you.
Yep. Alrighty. So let me give you a quick update on the KAS remote telescope. There's not much to report. Apparently Mike Patton is now out at ASV. He said he drove 3 days to get there. So hopefully he'll get the roof up and going, and we'll have access to the observatory again. And hopefully he'll have good luck installing the new night crawler focuser. And the Takahashi will be more powerful than ever once we get that thing going. And then our observatory update. I just since we had a talk on planetary imaging tonight, or at least a demonstration on planetary imaging, I just wanted to remind everyone that's a member and lives in the area about the Leonard James Ashby telescope with an owl observatory at the Kalamazoo Nature Center. So let me scroll down to the bottom here, and you can see one of our more recent acquisitions. Not only do we have the ZWO ASI 071 camera that you can use for both really deep sky and planetary, but mainly for deep sky. But we recently got a ZWO ASI 462 color camera that's more specifically geared toward planetary imaging. And we have, of course, a UV IR pass filter. We have the ZWO atmospheric dispersion corrector. We got that after Agapios' presentation back in February. And then of course, we have a Kendrick off-axis filter if you want to do sunspots with the 16-inch. We have a 90 millimeter hydrogen alpha filter for the teleview if you want to do H alpha solar imaging. So we basically have a complete suite out there. We have normally the laptops out there. It's not right now. It's actually sitting over here because I tend to bring it home for the winter. But we do have fire capture on there. We have MetaGuide. So we basically have a fully equipped observatory out at the Nature Center to do planetary imaging. It just has to be, you know, clear. So I just want to continually remind people about the resources that we have at our disposal. You know, we have a great scope here in town. We got a fantastic telescope out in Arizona. And I just, again, I'm going to keep reminding people that I know everyone has their own equipment, but you know, it's Michigan, it's going to be cloudy. So hopefully we'll get some use for the remote telescope. So is there any other astrophotography related items anybody wanted to bring up? If not, Pete, you want to give us a preview for next month's presentation?
Yeah, I'm going to be talking about flat fields, taking them, why we need to take them, proper techniques, some pitfalls to avoid from what I've been learned over the years from in different types, what you can use, whether it's sky flats, little light panels you get off Amazon or commercial units. The remote telescope does have one of the best ones out there from Optech. They have a big, nice light panel. So yeah, we'll go through all that. It really improve everyone's images. I mean, it's I know a lot of software packages have, you know, stuff that you can do to kind of simulate using a flat field, but there's nothing can really replace a flat field that gives you the best. So yeah, I'll try not to put everyone to sleep this time. I'll kind of keep it a little bit shorter than my last one.
Yeah. Yeah. I'd especially like to see like maybe some processed images with no flats.
Yep.
With
Oh yeah.
Similar processed image with flats. So you'd see the difference.
Yeah. I do have that lined up. I use the Pix Insights DBE tool, which can be used to correct for stuff. And then I have one that's with the flat. So yeah.
Great.
Yeah. They're easy to do. They just take a few seconds to, I don't say a few seconds, but a few minutes and you're done.
All right. So if there's nothing else, we will go ahead and adjourn. So thanks for joining us for the November meeting of the KAS Astrophotography Special Interest Group. We'll see you next time.